Today we are going to take the first exercise of this Pythagoras. Okay, see first here. In this topic or in this practice set, first question is what? We are going to verify or we have to check the given set of numbers is Pythagorean triplet or not. And you know how we are going to verify. See here, these are the first three sums in which we are going to verify. See first, it is a set of three numbers and we are going to verify this is the set of the numbers which are the sides of the triangle. Okay friends, see first how we are going to check. See here, let A equal to 3, B equal to 4 and C equal to 5. These are the three sides of a triangle. So we'll take the first bigger one which is C, that is 5, square to both sides. What do we get here? C square is equal to 25. This is equation number 1. That one already you know here. And remaining two A and B, here take A square and plus B square. So this is 3 square plus 4 square, which is 9 plus 16, that is 25 again. So from 1 and 2, what we can write here now? This is nothing but C square is equal to A square plus B square. Means what? Square of largest side is equal to sum of squares of remaining two sides. Okay? So therefore we can write here given set of numbers is a Pythagorean triplet. Okay? Like this. Okay, very similarly we can solve this one also. Okay, let here also see how simple all these are. Again take A is equal to 4, B is equal to 9, C equal to 12. Take the greater one, C equal to 12. Make the square to both sides. Okay, so what you can get here? C square is equal to 144. Right, equation number 1. And remaining two, A square plus B square. Remember, not always C is only the largest one. Okay, here coincidentally C equal to 5 and here C equal to 12. Both are greater one, but not always. Okay, so A square means what? 4 square plus 9 square. Here it is 16 and here it is 81. Is it correct? See, first always try to check. Here 4 square 16, 9 square 81. So their sum is what? 97, which is equation number 2. So from 1 and 2, what we can write now? Tell me whether these two are same? No. So therefore we can write here C square, which is not equal to A square plus B square. Therefore what we can write here? Given set of numbers is not a Pythagorean triplet. Not a Pythagorean triplet. Understand? Very simple. This is the first example in which this is a Pythagorean triplet. Here it is not a Pythagorean triplet. This is the way. Here also we solve here. See first again, let A is equal to 5, B is equal to 12 and C equal to 13. Take the greater one. Okay, therefore square to both sides. What you can write here now? C square is equal to 1. 13 square, that is 169. This is equation number 1. And A square plus B square, that is how much? 5 square plus 12 square. This is 25 plus 144. Again their sum is what? 169. Therefore from 1 and 2, what you can write? C square is equal to A square plus B square. Therefore, we can write here given set of numbers is a Pythagorean triplet. Okay friends, understand? This is very important. Very similar examples we can solve now next one. Okay? Remaining examples are Okay, here also very similar. Take here, let always write A is equal to 24, B equal to 70 and C equal to 74. Okay, take that greater one. Okay, square to both sides. So C square is equal to, what is 74 square? Make it here. Okay, 74 square. There are so many methods to write the square of any number. Okay, see here, 4 square, 60. Okay, now 7 4s are 28. Make the double. Yes, 7 4s are 28. Make the double. 56. 56 plus 1, 57. Carry 5. 7 square, 49. 49 plus 5, 54. 5 4, 7 6. Okay, you can make or you can calculate this side also. Okay, this is the first one. And similarly, next one, A square plus B square. 24 square plus 70 square. So 24 square, it is obviously we know here 576. 70 square, it is 7 square 49. Here it is just 1 0. So write 2 zeros. So how much the addition of this one? Yes, write 6, 7, 9 plus 5, 14. Carry 1, 5. Finish. This is equation number 2. Whether 1 and 2 are same? Yes. Therefore, again what we can write, from 1 and 2, given set of numbers is Pythagorean triplet. Okay? Here also we can write, here also very similarly part here. Okay? See here, let A is equal to 10, B is equal to 24, C is equal to 27. Which is the greater one? C. Here in textbook sum, every time C is only greater, but that is not always. Okay? So right now C is equal to 27, square to both sides. Very simple it is. C square. What is 27 square? Yes? Make the here. 27 square. So 7 square, 49. 2 7s are 14, 14 2s are 28, 28 plus 4, 32. Okay, and 2 square 4, 4 plus 3, 7. Like this we can write the squares. Okay, now remaining to A square plus B square, it is 10 square, and here it is 24 square. It is 100 plus 576 is no. And here how much? 676. This is equation number 2. Whether these two are same? No. From 1 and 2, yes, given, or you may write here first C square, which is not equal to A square plus B square. Okay, or you may write here first, after writing 1 and 2, here you can write here C square, which is not equal to A square plus B square. Therefore, given set of numbers is not a Pythagorean triplet. Okay? See how simple all these are. Here also we can make the very similar part. Okay? See here. Let A is equal to 11, B is equal to 60. Students, you can also solve all these examples. Okay? See first. Make here C is equal to 61, which is the greater one. Write square to both sides. Okay? C square, 61 square. Tell me how much? 61 square. Yes, that one you should know every time. That is nothing but 3721. Make somewhere and write here. Okay, this is equation number 1, and remaining A square plus B square, which is 11 square plus 60 square. This is 121. Here also very similar. 1 0, right? 2 times 0, 6 square, 36. So here it is 3721. So from 1 and 2, what we can write? Yes. This is nothing but C square is equal to A square plus B square. Therefore, you can write given set of numbers is a Pythagorean triplet. Okay, friends, see how simple all these are. All 6 examples we solved here. Okay, try to make yourself, prepare some triplets yourself. But in previous class, I tell you that one formula how to write the triplets here. Make triplets and try to verify them. Okay, we'll take next one now. in the question number 2. If you observe here, question number 2 and question number 3, near about very similar examples. So we'll write one by one. Okay, see here. What is in this question number 2? In triangle MNP, angle MNP is 90. This NQ is perpendicular to MP. M dash Q dash P is here. And this NQ is 9, QP is 4. From this information, we are going to find this NQ. Yes, try to observe, try to think which property we have to apply. Yes, yes, this is by geometric mean property. Always students, try to think here. This is right angle, means it is right angle triangle. And here on hypotenuse there is one perpendicular. At that time, there are two options. Either here three triangles are similar or geometric mean property. Here we need this NQ, means obviously we have to find use geometric mean property. Yes, see here in triangle MNP, angle MNP is what? 90 and NQ is here perpendicular to MP. Okay, therefore by geometric mean property. Yes, what you can write? Here, you should write here NQ square is equal to what? NQ into QP. Like this. So just try to put the values here. Okay, what is NQ? Here it is 9, this is 4, 9 4s are 36, this is NQ square. But what do I have to write here? Taking square root to both sides. So tell me how much? NQ is equal to how much? 6. Finish. Very important example these are. Okay, in every year these kinds of examples must be in exam. So students very carefully try to think here about this example. Very similarly here also, only what is difference? Instead of finding MR, we have to find this full QR. Very simple. But we cannot find QR directly. First you should find this MR. And then by between this, we can write adding QM plus MR, we get QR. Can you solve? Yes, try to solve. Okay, I'll solve here. See, in triangle QPR, here QPR which is 90 and here PM which is perpendicular to hypotenuse. So again by geometric mean property, PM square is equal to QM into MR. It is correct? PM which is what? Geometric mean, which is the square of that one is equal to product of two parts of hypotenuse. Okay, now I'll put the values. What about PM? Here, in previous sum, that one we find. Now that is given. Okay, what about QM, which is 8 here, and MR we are going to find. So what about 10 square? 100. 8 comes in denominator. Don't write minus 8. Okay, here this product. Okay, 8. This is MR. So tell me what about MR? 8 ones are 8 ones are 2 remains. Yes, 2 remains here. 20 means what? 8 twos are 16. Again 4 remains. Point 40. 8 fives are. MR is equal to 12.5. Now by between names Q dash M dash R. We need QR, no? That is why after finding MR, we have to find this QR. What about QR? QR is equal to QM plus MR, in which we have to just add with this QM, which is 8 and this is 12.5. Okay? Now again, here by adding, don't add this 8 to 5. Okay? Here it is 8 means what? 8.0 means this, we write here this 0.5 as it is. 8 plus 12 which is 20. This is QR. Yes, like this we can find. Yes, try to observe, think and try to solve. Here, now in the fourth sum, just try to observe here. Okay, and after observing, we are going to find this PR and SP. Okay, let's see here. What you are going to think here? See first, this is right angle. This is 30, means tell me remaining angle, definitely you can write here what? 60. Understand? This is remaining angle of triangle. Why? Because in every right angle triangle, remaining two except right angle remaining two are complementary. Because of here 30, this is 60. Okay? Now just try to observe. Which side we know here SR, which is side opposite to 30. We know the property in right angle triangle. If the triangle is 30, 60, 90 triangle, then side opposite to 30 is always half of hypotenuse. Means now it is, we have to find hypotenuse. So it is double of side which is opposite to 30. Okay? By that we can solve. In triangle PSR, okay, here that PSR which is 90, angle P is 30, therefore angle R which is 60, we can write what? Remaining angle of, you can write remaining angle like this, okay? Now, therefore what you can write? Triangle PSR is 30, 60, 90 triangle. Okay? Now, because of that reason, we can write now side opposite to 30 degrees. Who is there here? SR, which is half of hypotenuse. Who is hypotenuse here? PR. But this SR we know here. What is? That is 6. Okay. Therefore, how much PR? This PR is nothing but 6 2s are 12. Understand? Now, what is remaining? We need now SP, which is opposite to 60. Tell me what? Opposite side of 60 is what? Always root 3 upon 2 times of hypotenuse. Okay. Now hypotenuse we know here. So what we can write here now? Side opposite to 60 degrees is what? That is SP, okay, which is root 3 upon 2 times of hypotenuse, which is PR here. Now I will put the value PR, that is root 3 upon 2 into PR, 12. So 2 1s are 2 6s are, that is 6 root 3, which is here SP. Understand? Here PR and SP both we have to find. Look here, using side opposite to 30 degrees, side opposite to 60 degrees, like this we can solve. Okay, now here the fifth sum, which is activity based example. Only we have to fill the boxes. Try to observe. First, in this triangle, it is right angle triangle. Yes. Now, because of this is right angle, here we know AB equal to BC. They're given to us. Now, they're given to us AC, which is root 8 also given. Now, whenever the triangle, which is right angle, and as well as it is isosceles triangle, then we can take always it is what? 45, 45, 90 triangle. Remember it is always. Why? Because if these two sides are same, then their opposite angles are same. And because of it is right angle, then their sum is what? Complementary means their sum is 90. So though both are same, means both are 45, 45. Okay friends? Now, AB equal to BC. Who is given? That is given part. AB and BC. Who told us? That is given. We can write here it is given. Afterwards, what about BAC? What is BAC tell me? Just our discussion. What tells us? Because of this right angle, their opposite angles are same. Yes, and AB and BC are same. Okay. Therefore, each angle is what? 45. So we can write here 45. Okay. Afterwards, now AB equal to BC. What these are? AB and BC are what? Sides opposite to 45 degrees. So here, both these are 45 opposite sides. Okay. So what about 45 opposite side? 1 upon root 2 into hypotenuse. Remember, 1 upon root 2 into hypotenuse, which is AC here. Now AC is given, which is root 8. Here we can write root 1 upon root 2. Now what about root 8? We know 4 into 2, take 4 outside, so 2 root 2. Now again I will write here 1 upon root 2. So in the simplification, this root 2 getting cancelled. 2 ones are 2. What is this 2? This is nothing but AB and BC. So we'll write AB and BC both are 2 each. Understand? Like this we can solve. Now the sixth sum. In sixth sum, what they are given to us? They are given to us diagonal of square, that is 10 centimeter, and from that we are going to find side of that square, and similarly we have to find what? Perimeter of that square also. See what they are given to us. Diagonal of square, which is 10 centimeter. We know that formula. What is that formula? Diagonal of square is equal to root 2 into side. Remember that one is very important. I'll write here. Diagonal of square is equal to root 2 into side. This is one of the very useful formula. Okay, now I'll use that one. So diagonal of square is equal to root 2 into side, in which I will put the value, that is 10 here. So root 2 into side. Take that root 2 to this side. 10 upon root 2. Okay. Now whenever the denominator is irrational, at that time we are going to make rationalization. Remember, that is very important. Okay. 10 upon root 2 into root 2 upon root 2 is equal to side. So what do we get here? This is 10 root 2 and denominator root 2, 2. So here it is side. So now 2 ones are 2 5s are. So side of square is equal to 5 root 2 centimeter. Understand? Okay, now after that, perimeter of square. What is that? 4 into side. So just we find that side how much? 5 root 2. So just look here. Every time very carefully try to give the concentration. Here 4 5s are 20 root 2. This is perimeter of square. Okay. Now after that, okay, sometimes they can ask by using that diagonal we can find area also. So by that area, how can find using the diagonal? See here, from diagonal we have to find side, and after getting side, we know the area of square, which is what? Side square. Suppose no need to find that side, straight away by diagonal also we can find. See, diagonal of square. Here it is the formula. Okay, diagonal of square is equal to root 2 into side. No, we need only side. So take here side. This root 2 comes this side. Means side means what? Diagonal of square upon root 2. Okay, but square, area of square means what? Side square. So means what? Side is nothing but diagonal upon root 2. Means what we will get here? Area of square. With diagonal given, at that time you can write here square of diagonal upon 2. Why 2 here? Root 2 square means 2. Okay, using that also we can find the area. Now here in the second sum, try to observe here. The given triangle is DFE is what? Right angle. Okay. Now FG, which is perpendicular to hypotenuse. Okay. Where G is in between D dash, G dash, E. Now here this is DG is 8. This geometric mean, which is GF, which is 12, it is given. By using that one, this and this means what? EG, EF and DF, all these three we are going to find. If you observe here, this is right angle, here it is perpendicular, means what? There are two properties. First, geometric mean, and second one, all the three triangles are similar here. This one, and bigger one. All the three triangles are similar. We know right angle triangle and its area. Okay, that is always similarity. Okay, by using that property we can write. Now first of all we are going to find EG by using geometric mean property. Yes, see first. In triangle DFE, where angle DFE is 90 and FG, which is perpendicular to D. Therefore, by geometric mean property, what you can write? GF square, which is equal to product of these two, that is EG into GD. I'll put the values here. What we know? What about GF, which is 12 square? EG, that one we are going to find. What about GD? 8 here. Okay. Now 12 square, you can write here 144. Take that 8 in the denominator. So now what do you have to find here? EG. So now whether it is divisible? Yes. See here, 8 ones are 8 ones are here, 6 remains. 64, 8 8s are. That means EG is equal to, okay, see here. Now in this one, we are going to find this DF and EF, and that will come after using Pythagoras in this triangle and in this triangle also. Okay, see first, in right angle triangle DGF, in right angled triangle DGF, okay, by Pythagoras. Okay, what we can write here now? This is DF square is equal to DG square plus GF square. Put it here. DG 8 square, GF 12 square, 8 square 64. This is 144. Tell me how much? Here 64. Okay, here 144. How much you get here? 4 4 8 6 and 14. It is 20. This is DF square. Taking square root to both sides. Okay, what we'll get here? That is DF. How much? 208 here. Yes, write first 218 root side. And if possible, 208 also, we can make the split. Yes, how can write? Maybe you can solve like this also. See first here. 2 1s are, 0s are, 4s are. 2 5s are, 2s are. Okay. And here again 2 26 are, 2 13s are. And 13 is a prime number. Now here, like this, make the pairs here. Here 2 2 4 and 13. Like this we can make here 4 root 13. Yes, how will you find that one? See here, these 2 2s are, just write once only. Here also write once only. This 13 is not pair. So keep that one inside only. Like this 4 root 13. Okay, similarly, and in right angled triangle downwards, EGF. Okay. Here also by Pythagoras. Okay. What you can write here? This is here EF square, which is equal to EG square plus GF square. Put here. What about EF? That is only we have to find. EG, we just get that is 18 square. What about GF? This is again 12 square. 18 square. Yes, 18 square. Try to observe. 18 square. 3. You can make here 18 into 18 if you don't know. 18 is a 144. Okay. 18 was 18 plus 14. 32. Like this you have to find. 324. And what about this 12 square? 144. Just make addition here. 4 4 8. 2 plus 4 6. And here 3 plus 1 4. It is EF square. Again here also square root to both sides. What much you get here? This is EF, right under root 4, 68. So here also you can make what? Factorization. What is that? 468. Make it here by 2s. Why? This 8 is what? Even number. So 2s are, 2 2s are, 2 3s are, 2 4s are. It is correct? Again, 2 1s are, 2 1s are, what remains 7s are. Now this is by, obviously 3s are because the sum is 9. 3 3s are, 3 9s are. Okay. Now again 3 1s are 3 3s are. It is prime. Now keep as it is. Now see here. From this write just once. From this write just once. Means what? 2 3s are 6 and 13 is a just single number. So you can write here 3 2s are 6 root 13. Like this you can solve the example. Where are the two numbers you find here? This is EF and here it is DF. Like this you can solve here. Understand, friends? See students, in 8th sum, what they are given to us? There is one rectangle. Okay, there is one rectangle. And here we are going to find that diagonal of that rectangle. So they were given to us what? The length is 35 centimeter and breadth is 12 centimeters given. Okay, see that one you are going to solve. See friends, this is a rectangle in which this is length and this is 12 breadth. So from this we are going to find diagonal of rectangle. See how you are going to solve this one. First write ABC is a rectangle. Let naming here. Okay, because of it is rectangle, this triangle should come here now, right angle triangle. If you observe here, this is right angle triangle, apply Pythagoras, then you can find this diagonal. Okay friends, it is very simple. Try to solve here. Okay, only make the square of 12 square, okay, and here 35 square, make addition, whatever be the number will get here, take the square root of that number, then we can find this particular diagonal. Try to solve this. Okay, now, with the 9th sum, in this figure, if you observe here, here it is a right angle. Okay, M is the midpoint of RQ, it is given. Okay, so here PRQ is a right angle triangle. M is the midpoint of RQ, means RM and MQ both these are same. Okay friends, so what we have to prove here? So I'll write first given part. See, what is given? In triangle PRQ, angle PRQ is what? 90. Is it correct? With the same time, RM and MQ both are same. When M is midpoint of RQ. So from this, what we have to prove here? This is very important. So here, PQ square, this one, square is equal to 4PM square minus 3PR square. This is our aim. This is our proof. Okay, see how we are going to prove this one. It is again very important example. Make the mark. Okay, such kinds of examples must be in your exam. Okay friends, see how we are going to solve this one. Just try to observe here. How many triangles are there? Obviously there are 3 triangles. Yes, this is the bigger one, this is this side and that is again one triangle. Out of these 3 triangles, how many triangles are right angle triangles? Yes, 2 triangles are right angle triangles. Okay, here PQ, which is the hypotenuse of the bigger right angle triangle, and PM is the hypotenuse of smaller right angle triangle. Okay, so now what we need here? PQ square means we have to apply what? Pythagoras in bigger one. Okay, for PM square, here PM again means what? In smaller again also we have to apply Pythagoras. And here 3PR square means something like we have to put up here RM MQ is what? That one we are going to write. Okay, first I am going to apply Pythagoras in the bigger one. But before that one I will write the given part. What is given part? RM and MQ both these are same, which is given. Okay, now in bigger right angle triangle, okay, in right angle triangle we can write here in right angled triangle. Which one? PRQ. Okay, apply Pythagoras. What we can get here now? Yes friends, PQ square is equal to PR square plus RQ square. So this is by Pythagoras. Okay, now keep this one as it is. Okay, now in smaller one, in smaller triangle, right angle, and in right angled triangle, which one? PRM. PRM. Okay, here also we are going to apply Pythagoras. What is that? PM square is equal to PR square plus RM square. Is it correct? Again here also write Pythagoras. Now try to observe here. What we need here? 4PM square. Means here only PM square. We can multiply to both sides by 4. See first. 4PM square, okay, is equal to 4PR square plus 4RM square by multiplying to both sides, okay, 4. Okay, just try to observe here. What we'll get here now? This is 4PM square, here it is 4PR. Keep that 4PR square as it is, okay friends? Now, what about this 4RM square? 4RM. May I write here 2RM bracket square? 4 is square of 2. RM square. Yes, we wrote RM square. That is 2RM bracket square. This is from step number 4. Now, the next step is what? 4PM square. 4PR square. What about 2RM? Choice of RM. This is nothing but, I will write here RM and MQ. Both these are half of RQ. Is it correct? Because M is midpoint. So, twice of RM. 2 comes this side. Twice of RM is equal to RQ. We can write here RQ square. This is very, very important. This is from 1 and you can write from 5. So now, what is the next step? Just try to observe here. What we need? We need only 3PR. I split here. 3PR square plus 1 PR square. So instead of writing 4 PR square, write 3 PR square plus 1 PR square. This is RQ square. Keep as it is. This is from 6th step. Now try to observe friends. What is this? Look here. PR square plus RQ square means what? Here it is. PR square plus RQ square means what? It is PQ. Look. Our proof will be completing now just within 1 or 2 steps. So this is nothing but what? PQ square. Is it okay? This is from 2 and 7. Okay, now the next step is what? Here 3PR square to this side. So this is the last step, friends. Okay? This is from 8th step. Understand? These kinds of proofs are very, very important. Try to observe. Sometimes these examples we can solve. Sometimes instead of multiplying 4, you can write this RM square, which is nothing but half of RQ. Right? Like that also we can write. So we can write here RQ upon 2 bracket square. So square means RQ square upon 4. So multiplying to both sides by 4. Like that also we can simplify. Understand? This is very, very important, students. Now the last sum of this practice set. See here. There are the 2 buildings. In between them there is a street. Okay. See here. This is the street or width of street. Here it is the wall of first building. See here. Wall of first building. And this side there is one wall of other building. Okay. Building means obviously it is perpendicular. See here, these are the 2 buildings or walls of buildings and this is a road. Okay, this is width of that street here. Okay, there is one ladder. Okay, there are the 2 windows are there also. Okay, see, this is a point of foot of that ladder. Okay, of 5.8 meter length of that ladder. Okay, put on the point. We'll take one point here on the street. Okay, now this is a ladder. See here. This is a ladder. Okay, and just reaches to the window of first building. Suppose it is a window. Okay, this is a 5.8 meter. Okay, now this is a 4 meter height. The window is there. Okay, similarly, same procedure here. We have to just rotate this ladder to that side. Okay, that side. So here that wheel goes to like this here. Okay, friends. Here also one window, but at height of 4.2 meter height. Okay, see, same ladder here also 5.8 meter. So we are going to find the width of that street here. How simple it is. Only try to understand the meaning of that example and try to draw one proper figure, and then it is very easy to solve this one. Okay, see first. This is right here. AB is the first building, CD is the second building, BD is the street of that road. Okay, and this AM and MC, both these are what? The length of ladder. Okay, write first here. AB and CD are two buildings. Okay, now here, this AM and CM are a ladder and they are of length 5.8 meter. Okay, here this AB is how much? 4 meter and CD is 4.2 meter. Now look here, where M is a point on BD, which is street or road width of that street. Okay, like B dash N dash D. That BD is nothing but width of street. Understand? Now, what we are going to make? Just apply 2 times Pythagoras. Finish. In this triangle apply Pythagoras. Here also apply Pythagoras. Find DM and MD. Then by adding these two, finish. Okay, see here. In right angled triangle, which one? ABM. By Pythagoras. What you can write here now? AM square is equal to AB square plus BM square. Is it correct? Now I'll put the value. What about AM, which is 5.8 square, AB 4 square, BM we have to find. What is this 5.8 square? See here, make the square, or there is one more option. Like we are going to use that a square minus b square. So 5.8 plus 4, 5.8 minus 4. Okay, whenever like this one, then at that time we can use like this one also. So what will get here? Here 9.8 into 1.8 is equal to bm square. You can make multiplication also, but instead of multiplication, we are going to make some tricks. See here. May I write here, this is nothing but 4.9 into 2. Is it okay? Here 1.8 is equal to bm square. Now again I will write here, this is 4.9. This is what? 3.6 bm square. Is correct? See, I think you understand what I am going to make here. Okay, see first. Here 49 by 10 into 36 by 10. This is bm square. Taking square root to both sides, here it is, this is 7, this is 6, and here it is 10. Understand? Here it is 7 6 are 42 upon 10 means here it is 4.2. Understand? So similarly, that side in this triangle also, and in right angled triangle, which one? CDM. Here also by Pythagoras. Here this CM square is equal to what? CD square plus MD square. Now you put the value. This is 5.8, very similar. This is 4.2 square and MD square we have to find. See, very similar part, only we have to repeat here also. 5.8 square minus 4.2 square. This is MD square. Again I'll write 5.8 plus 4.2. 5.8 minus 4.2. This is MD square. Tell me how much here? 8 plus 2, 10. 10 carry 1 means here only 10.0 means 10 into here. 5.8 minus 4.2. Yes, look here. Here 6. 8 minus 2, 6. 0.5 minus 4, 1. Like this. Okay. Now 10 into 1.6 merit only 16. Now taking square root to both sides, here MD equal to 4. Understand? Now we need BD. This is what? The width of slit, which is BD. So that BD is nothing but BM plus MD. Already BM, already we find that is 4.2 and here it is 4. In this way, we find this is the width of the slit. Understand?